I'm Nech. I'm here with Kemelmacher, presenting a level playing field for million-scale face recognition. To motivate us, we previously ran this large face recognition benchmark called MegaFace 1. And during this benchmark, we noticed that although the participants were getting better over the years, the top performers, such as vote quarter, that were 91%, they're private companies and they might have private data sets, and we weren't sure if their algorithms are winning or if it's because they just have massive data sets. And so we're asking ourselves, who has the best algorithm here, as opposed to just the best data set? And so to answer this question, we need a data set that's analogous to these private data sets, that has non-celebrities, has many, many identities, and that just doesn't really exist right now. And so what we introduce here is a large-scale face recognition benchmark, which is to train on the same data and test on the million scale and let the best algorithm win. And our new data set has 672,000 identities and over 4.7 million photos. So to build this data set, we utilized the Flickr 100 million data set. It has many photos, and we extract 40 million faces. We then push clustering to its limits here and extract Euclidean embeddings with VGG face network. We then automatically cluster these faces into identities, and then we also fully automatically optimize the clusters to remove as much noise as possible. So clustering works as follows. We take these two faces in the embedding. We see if we can link them via assumptions in the paper, and then we see if their distance is less than a parameter beta times the average distance in the Flickr account, and beta is learned from labeled data. Great, they're linked, and so now we can find these clusters and get them via connected graph components. So now that we have clusters, we remove noise as much as possible. We take the clusters and calculate the average pairwise distance in the cluster in the embedding. We then use the median absolute deviation over a threshold alpha to detect the noisy clusters. We then, for each face, calculate a score based on the sum of the distances between it and the other faces. And we find the noisy faces with the same median absolute deviation and remove them over the same threshold. That reduces the pairwise distance in the cluster, and if it's acceptable, then we keep it, otherwise we throw it out. And these two parameters, alpha and beta, were learned from labeled data such as face scrub. So the result is that we have over 672,000 identities and 4.7 million faces, which is really exciting. Here's a example identity from the data set showing different orientations, resolutions, accessories. And here's one in particular that shows different resolutions and lighting conditions. So now we have this new benchmark, and it's currently being led the way by GRCCV with over 75% rank 1 accuracy. This is to train on that same data and test up the million scale. And yeah, it's exciting. The results are similar to MegaFace 1. And so to conclude, the key discoveries here are that one, algorithms trained on the new data are actually performing comparably to MegaFace 1. Secondly, some participants actually outperformed their MegaFace 1 score, which shows that they didn't have access to the private data and now they can do better. And then finally, participants still score pretty badly on the FGNet part of the challenge, which identifies a need for a data set that has a large age variation within identities. And so yeah, you can participate at megaface.cs.washington.edu. We currently have over 1,000 people with access to the data, and you can be one too. Thanks.